Hello, this is a not-so-short video presentation on solving by the Gauss-Jordan elimination. This is not something we would normally do with a system of equations with two equations and two variables. This is something we use for bigger systems. However, it's much easier to learn how to do it on a small system than on a big system. Truly, the easiest way to solve this system of equations is with elimination. But we want to be able to solve three systems of equations with three variables, three equations, four variables, four equations, and so on. Also, with this method, we can easily write a computer program to solve systems of equations. So, step number one, which I did for you, we put the equations in standard form. Check. Now we need to write down the augmented matrix. That's nothing more than a matrix with the coefficients and constants. What is that? This notation means matrix. We write down just the coefficients and the constants, and we separate them by a bar. And for -5 and 14. Now we want to manipulate this to make it look like this. 1, 0, 0, 1, up, horizontal, vertical bar, AB. This column signifies the coefficients of x. This is the coefficients of y. This is the constants. This row is the first equation. And this row is the second equation. So if we can manipulate this right here to look like this, then we would have 1x plus nothing equals a, or x equals a, and likewise we would have y equals b. So we're going to use basically nothing more than elimination. It's going to look really, really, really like elimination. Now when you do this, you can go sideways, or you can go down. Personally, I think going down is much better. Much, much better. But it's up to you. If you go sideways, you do run the risk of getting lost. And if you're not neat, you will be lost. You will struggle, struggle, struggle if you are not neat. Be extremely neat. So let's go. So we have, I'm going to rewrite this, 2, 4, 3, -5, -4, and 14. What we want to do is make this guy right here equal to 0. So we're going to take this, the first row, multiply it by -2, add it to the second row, and we're going to replace the second row with that. I want to see this notation right here. Tell me what you're doing. Multiplying everything in the first row by -2, adding it to the second row, and that becomes my new second row. So I have 2, 3, -4. -2 times 2 is -4, added to 4 is 0, voila. Negative 2 times 3 is negative 6. Added to negative 5 is negative 11. Negative 2 times negative 4 is 8. Added to 14 is 22. Now remember, I want to see a 1 here. So I'm going to take the second row, divide it by negative 11, and I'm going to replace the second row with that. Probably a better way to write that would be like this. Row 2 divided by negative 11. And notice I'm using subscripts. I am not using anything else. So I have 2, 3, negative 4, 0 divided by negative 11, 0. Negative 11 divided by negative 11, 1. 22 divided by negative 11, negative 2. So, what did we do? We always start here and work down, making the entries below me 0. Once I have that, then I go up and I want to make this equal to 0. So I'm going to take the second row, I'm going to multiply it by negative 3, I'm going to add it to the first row, and I'm going to replace the first row with that entry. So this stays the same. Negative 3 times 0 plus 2 is 2, no change. Negative 3 times 1 is negative 3, plus 3 is 0, awesome. Negative 3 times negative 2 is 6, added to negative 4 is 2. That is the worst looking 2. Absolute worst looking 2 that I've ever seen. Alright, now I'm almost done. I want this right here to be a 1. So I'm going to divide by 2. Row 1 divided by 2 is going to replace row 1. So 0, 1, negative 2, that's unchanged. Divide row 1 by 2. 2 divided by 2 is 1. 0 divided by 2 is 0. 2 divided by 2 is 1. So I have x equals 1, y equals negative 2. And I'm done. That's all there is to it. So I have 1, negative 2. Alright, we're going to do one more example. It's really important that you understand this. Alright, here's our next system. We're going to start with the augmented matrix, negative 7, negative 4, negative 5, 5, 9, and 22. Now, I want to have right here a 0. So what I'm going to do is take the first row times 5, add it to the second row of negative 7 times row 2, and I'm going to replace the second row. This is exactly what we did in elimination, when we multiplied the top equation by 5, the bottom equation by 7, and that should be a positive because I'm adding. All right, it should not be a negative. So when we took the top equation by 5, bottom by 7, added them together, we got 0. That's all we're doing. Nothing new. So, times 5 is negative 35, times 7 is 35. Well, let me write this first. Negative 7, negative 4, negative 5. So we get negative 35, positive 35 added together is 0. Now we have to be careful. We have negative 4 times 5 plus 7 times 9, or negative 20 plus 63 is 43. I'm sorry, 5 times negative 5 is negative 25. 7 times 22 is 140, 154. Added together is 129. All right, hope my math is right. And now I want to make this right here equal to 1. So I'm going to take row 2 and I'm going to divide it, what am I doing, by 43, and that's what I'm going to replace row 2 with. So I take and rewrite my top one, negative 7, negative 4, negative 5. 0 divided by 43 is 0. 43 divided by 43, 1. Check. I want that. 129 divided by 43 is 3. Now, I want this to be a 0. So I'm going to take row 2, multiply it by 4, add it to row 1, and replace row 1 with that. So I have 0, 1, and 3. 4 times 0 is 0, plus negative 7 is negative 7. 4 times 1 is 4, plus negative 4 is 0, kerchunk. 4 times 3 is 12, plus 5 is 7. Now, I want this guy right here to be a 1. That's a 1. So I'm going to take row 1, divide it by negative 7, and replace row 1 with that. So, negative 7 divided by negative 7 is 1. Voila. 0 divided by anything is 0. Voila. 7 divided by negative 7 is negative 1. And we have 0, 1, 3. X then equals negative 1. Y is equal to 3. And my solution is negative 1, 3, written, of course, as an ordered pair. All right. Wow, this is the longest video I've made in a long time. But we still came in under the 15 minutes. All right, have a great day, and remember, above all else, go Pack Go. Have a great weekend, guys, and I love you.